All right, hello and welcome to part 3 of the fossil fuel lecture. This lecture is going to focus on natural gas. All right, so natural gas, like all fossil fuels, is produced from the decomposition of buried organic matter. And again, usually that organic matter is millions of years old. So most of it's going to be methane with smaller amounts of ethane, propane, butane, et cetera, but mostly methane, which is CH4. All right, so if you can liquefy it and you can then transport it as liquefied petroleum gas, if you ever see the words LPG or the initials LPG, that's what that stands for. And then usually if you're going to be transporting it, you're going to need a pipeline to get it from the field to your users. All right, so you will often find natural gas on top of oil deposits. And the problem is that for a lot of oil deposits, they're not set up to transport that gas anywhere. So what they will do is just burn it off. So we actually lose a lot of that natural gas to our atmosphere at oil wells because they're just not set up to have a pipeline to pipe it somewhere where we can use it. All right, so if you're looking at greenhouse gas emissions, the nice thing about natural gas is that it actually puts out more CO2 per gigawatt hour. That GWH is an energy measure per gigawatt hour compared to our other fossil fuels. However, compared to renewables, it still puts out a significant amount of greenhouse gas, mostly in the form of carbon dioxide. So it is better than the other fossil fuels, but not as good as our renewables. All right, so there's a couple different kinds. One is conventional natural gas. And again, I said most of your natural gas is going to be located above oil deposits. That's what they call conventional natural gas, because again, it's the most common. But there's also unconventional natural gas, gas that's locked up in impermeable rock, usually sandstone. There's something called shale beds where the gas is locked up in shale. There's methane located in coal beds, and this is partly what can make coal mining dangerous. And then locked on our ocean floor is something called methane hydrates that we'll talk about at the end of this lecture. So the ones with the asterisk, because they're locked up in rock, they require something called fracking, which we'll talk about also in this lecture. All right, so who's got it? Russia is #1 in the world for gas. We're #2. So we have a lot of natural gas reserves, all right? And you can look at China, Iran, going down the list, but just note that we have very large natural gas reserves in this country. All right, and then for production, look at United States, where you actually top Russia in production of natural gas. And this is in 2016 data, but realize this is a more recent development as our fracking technology has really taken off. Our ability to extract natural gas has really increased. All right, so where is it? First off, reserves and demand. We used to import it, but notice as our production has really taken off, we don't need to import it so much anymore. And where is it? We have natural gas deposits over large areas of the United States. So deposits being extracted are in orange, deposits we're looking at, and then shale basins. And so if you look at it, places where they do a lot of fracking are in Pennsylvania. They also do a bunch over in Montana over here. And we have very, very large deposits. All right, so what is fracking? Because fracking is how we're getting a lot of it out right now. So you have deposits down here that are loaded with natural gas, but it's locked in the rock. So what you do is you drill a well, and you can even go at right angles to go follow a bed underground. And once you drill that, you put that line down, what you do is you shoot fluids under super high pressure into that rock, and what it does is it fracture it. So fracking is using that word fracture as part of it. So when you put enough pressure on it, then you crack the rock and the gas is released. And because it's a gas, it's then easy to pipe out. So it's an interesting process. And again, you don't need a very large surface area of land to actually be able to tap into quite large areas underground. All right, so what are some environmental concerns? That fracking fluid is mostly water, but they put other stuff in it too, things that lubricate and whatnot. And the chemicals are like, up to 2% of the mixture. And companies don't always tell you what's in there. They say it's like, private, like they don't want to tell you their secret ingredients kind of thing. If you start fracturing the ground in a large way, you might allow for the migration of that gas and chemicals into other areas. And people in a lot of rural areas drink from well water. And so if you get that natural gas into their well water, they can start to have issues like their tap water is catching on fire. All right, so they also put radioactive tracer elements to see where the gas reserves are, and carcinogens are some of those fracking fluids. So So anyway, and these are just some, you know, of the stuff that they put in there. I didn't give you the slide because it's way too many chemicals to even think about, but just realize that they're probably not super healthy for people if they're drinking them in their well water. All right. The other issue with fracking is that in a place like Oklahoma, it has caused, they think the fracking is responsible for a large increase in earthquakes. Oklahoma is not exactly earthquake territory, and yet they've had up to like size 5 earthquakes there because of the fracking. And it's pretty clear that as fracking took off, so did the amount of earthquakes. And so this is another potential problem with fracking. All right, so just I want to show you this video because
one of the things that oil companies and gas companies and geologists always kind of knew is that there were pockets of oil and natural gas under big rock formations, big layers of rock that you couldn't get at by drilling straight down. So this process involves drilling horizontally. Fracking gets its name from hydraulic fracturing. And what that means, hydraulic, they're using water and a lot of chemicals and some sand and other things, and they fracture the rock by pushing it at a very, very, very high speed. That fractures the rock, it releases the oil and the natural gas. About 87% of the fracking that was done last year worldwide was done in North America. The Bakken Shale, which is out in North Dakota. You have the Marcellus Shale, which sort of spreads through New York and Pennsylvania. So that's the kind of rock, shale, that you find these oil and gas pockets underneath. The U.S. doesn't have that much oil or gas if you look at it compared to the rest of the world. And also remember, there are a lot of places in the U.S. where you can't drill for oil and gas. The government only allows it in some places. So they allow fracking in different places than they do, say, traditional oil drilling. It is also and can be less expensive to frack for natural gas in, say, Pennsylvania than it is to drill for oil off the coast of Louisiana. Whoa, Jesus Christ. This is the image that people know of about fracking, right? A drinking water tap catching on fire. That happens when you have methane in the drinking water. So what you hear from advocates, environmentalists, folks who live near there is that the drinking water is contaminated either because there's natural gas in it or because those chemicals that are being used to kind of push the fluid down into the rock, fracture it, that could seep into groundwater. A lot of these chemicals are dangerous, but we don't quite know exactly what's in it because nobody requires the companies to say exactly what's in it. And they say that if they told us the secret ingredients, that would put their business model at risk. This is the central debate about fracking, whether or not things get in the groundwater. The companies who do this say, no, it's completely safe, largely because there's space, there's a lot of rock in between the fracking operations and drinking water, be it wells or reservoirs. Fracking can bring a lot of money and a lot of development and a lot of jobs to an area that didn't have that option. So there are places in Pennsylvania, there are places in North Dakota that, because of fracking, have put a lot of their residents to work. Then also you have these companies who pay homeowners to be able to drill on their land, so they make money off of it too.
All right, so just another show. This one's on.
I can often hold a standard kitchen match to my water, and like I said, it is unpredictable, but the methane randomly travels with the water, and sometimes it will light quite spectacularly. Just like that.
All right, so that sputtering you saw, that was gas coming out of her tap. And some of the companies say, well, how do we know your tap wasn't doing that before we started fracking? And, you know, so the lawsuits are people who are upset with this. It's kind of hard to sometimes figure out that, no, my tap didn't do that. My sister lives in Pennsylvania, and she and her husband have well water. And they have had their water tested so that if there anything ever does happen, they're very close to fracking territory, that they will actually have, they'll be able to show that there was a change in their water. All right, so how do you get natural gas then? You guys, most of you probably heat your houses with natural gas. We need to have pipelines. They can go for hundreds of miles. And so this is kind of whether you bury them, or most of the time they actually keep them above surface so you can actually see if they're intact. And then they put them below ground in towns so that you don't have big pipes running up to your houses. But realize that underneath your house, if you have natural gas, you have a pipeline going to it. Pipelines can leak. So one of the things they do is they put a smell in natural gas so that if there's a leak, you will smell it. Natural methane does not normally have a smell, but they put that smell in, the gas company does, so that if you do have a leak, hopefully you'll smell it and you can call somebody to fix it before something catastrophic happens. All right, so just in our area, just so you know, we get a bunch of ours from gas fields up in Alberta and British Columbia, and then we also get some from over here in the Clay Basin storage area. So again, most of you probably heat your house with natural gas. That gas has to get to your house from somewhere. So again, think about the infrastructure that needs to be in place for this to work. All right, there is a big methane storage place that I'm not going to go into this here for this lecture, but realize it was leaking for a very long time before they were able to stop it. And there was a lot of effects on the local town. All right, so what happens then as that infrastructure starts to get old? Those gas lines can leak, and if you don't catch it soon enough, any kind of spark can set off an explosion, and there were houses here before, and they were blown up. So failure of a gas line can be highly catastrophic and lead to loss of lives. So again, they put that smell in the gas so that hopefully before something like this happens, you smell that there's a leak and you can get it taken care of. It can also happen at a natural gas plant. So you can also make electricity with natural gas, and so they combust it at the plant itself. And this happened in 2010, it looks like. I need to move my little, 2010. And again, catastrophic. I don't remember how many people died in this one. All right, so trade-offs, this again comes from your Miller textbook, so I'm gonna let you look at Miller for that. But realize we have been vastly expanding our gas production, mainly at the detriment of coal. So that is not an all bad thing because gas is cleaner than coal, but again, it's still a fossil fuel. All right, so finally, methane hydrates. Methane hydrates are basically a methane molecule encased in a lattice of ice. And it's really wild because that ice burns. And so like unlike dry ice, which is frozen carbon dioxide, methane hydrate is frozen methane, and it's highly flammable. Have you not heard of this or seen much of it? It's because it exists mostly on the ocean floor. You need super high pressure to keep it stable and super cold temperatures. So at normal, if you bring it up to the surface, it's gonna boil off pretty fast. And if any spark gets near it, you can set it on fire. So it's formed as a byproduct of little microbes living in the ocean sediments, and it's vast. We have huge, almost all of our coastline has a ton of this methane hydrate. So, and in fact, if you're looking at all of the carbon on the planet, this is distribution of organic carbon in Earth's reservoirs, gas hydrates make up a huge amount. So there is talk about, can we mine this stuff? Can we somehow extract it safely and get it and use it as a new fuel source? So people are always looking at new ways to get at energy production as our global demands go up. So, you know, and also just realize it's always been there. So that some people wonder if like past releases have led to climate shifts and whatnot. But right now we don't know how to safely extract it. There have been times where they brought it on board ship, and when they realize what it is, anyone lighting up a cigarette could explode their ship, so they shovel it off. So right now we don't really have a good way to use it. All right, but the future is the idea that maybe we could tap this stuff, use it, and then re-inject the CO2 we get from it back down into the ground, where it could make more methane hydrate. So it would be a closed loop, carbon neutral sort of thing. But again, I don't know how feasible that is. I think it's still probably pretty far off in the future. All right, so that concludes lecture part 3, and we will continue with coal for lecture part 4.